Hello everyone, we are DMD Hangar team, and today we are going to start the integration of our multiplayer shooter system into the game animation sample project. The first thing we need to do is download the most recent version of GASP. In our case, we will be using version 5.7. It's important to activate the plugins before migrating the DMD content. We'll enable common UI for the gamepad compatible interface. Also, set up the projectile and laser collision channels to block by default. This will be useful later on as we integrate the shooting mechanics. Before migrating, make sure the multiplayer shooter system project and the GASP project are on the same Unreal Engine version. In our case, we are using version 5.7 for both. Migrate the DMD folder into the content folder of your new project. This ensures all references and assets are transferred correctly. We are now going to configure the common UI plugin for gamepad compatibility. The multiplayer shooter system already includes the required blueprints. You just need to select them in the settings. The most important parts are the input data and the Windows section. Make sure to assign the correct assets here to ensure everything works perfectly. An important part of the multiplayer shooter system are the sockets. They are necessary for correct reload animations and, above all, the weapon's equipped position. To set them up, open the UE5 skeleton in the DMD folder, copy the sockets, and paste them into the root of our target skeleton. For this tutorial, we will start with the default GASP character, CMC. We'll add the shooter component, where you can configure the system using all these variables. Next, we'll add the holsters. To speed up the tutorial, we'll copy them from the DMD character. The system handles 3 holsters by default, but you can add or remove them as needed. Finally, we will add 3 initial weapons to the corresponding array to verify everything works correctly later. Remember that each weapon must have its corresponding slot defined in its details. The holster system has physics enabled to create a realistic sense of movement. However, you can disable them inside the holster blueprint if needed. Please note that the GASP movement system does not always work perfectly with attached physical objects. At high speeds, they might momentarily separate from the body. For the shooter component to know where to attach the holsters, we must add the root mesh tag to our character's skeletal mesh. With this, the shooter system is correctly set up within the character. However, there is still a vital step ahead, the animation blending between GASP and our system. We need to retarget all the necessary animations for the shooter system. We have significantly reduced the number of required animations to make the integration more streamlined and to keep the project size optimized. Furthermore, these animations will provide a higher quality visual finish, resulting in a much more natural look and feel. We recommend saving the newly retargeted animations in a dedicated folder and adding the UFN suffix to their names to streamline the process. This organization will make it much easier to locate and manage your assets during the integration phase. We will now begin with the weapon interaction animations, such as reloading, holstering, and drawing the weapon. These animations are stored within each individual weapon, so they can be completely independent if needed. In our case, we will update the animations in the master weapon VPs for each weapon type in a quick and simple way. In this new version, we have added distinct poses for every movement state: crouching, walking, running, and sprinting. To make the integration easier, we have streamlined this process using data assets. We must create a new data asset and populate it with our newly retarget UEFN animations. This allows the system to switch between poses seamlessly based on the character's movement. Finally, we assign the data asset to the shooter component of our character. We have simplified the MSS animation blueprint into a single overlay node, making it incredibly easy to add to any character. You no longer have to worry about complex setups, just place it in the right spot and you're good to go. The only thing left to do is determine which GASP states should correspond with the shooter system states to ensure perfect synchronization. To do this, we must add the BPI_locomotion interface to our character, which allows us to adjust each state of the shooter system. With this, the shooter system is now fully integrated. In the previous version, we encountered compatibility issues with Hipfire, but we have a solution for this version. You need to get a reference to the shooter system modes and add a condition so the character orients itself correctly while in this mode. Earlier, we added the specific collision channels required for the MSS. GASP's built-in traversable channel interferes with our projectiles and lasers, so we must adjust them to ensure physical projectiles function correctly. Simply set the object type of BP_projectile master to projectile. For the BP_laser master, set its object type to projectile as well, and use the laser channel for the line trace. Don't forget to apply these settings to the projectile path channels for grenade launchers and the object throwing system within the shooter component. The shooter system utilizes the built-in UE5 variable, can be damaged, which is enabled by default on all actors. The system uses this to detect and notify the player if a projectile has hit a valid target. Since GASP uses actors for its environmental cues, shooting the scenery would trigger a hit notification as if you'd hit an enemy. To avoid confusing the player, we must disable this option in the parent class of these cubes. In this example, we can see that everything is functioning perfectly. Movement is fluid, and all shooter system animations synchronize seamlessly with GASP states. But we're still missing one final part, the interaction and pickup systems. Let's get to it. We're going to quickly copy the weapons from the shooter system demo map, so we can use them in our project. For the interaction system, we need to add the BPI_interaction interface to our character. We've updated the system, so you can now interact by holding down the input. To save time, we'll copy the functions from the DMD master character, which already contains the necessary mapping context and replicated functionality. This ensures everything works perfectly without any issues. Interactable weapons use the physics body collision channel, so we need to add it to our character's capsule to ensure they can be detected correctly. Additionally, we're going to clear the initial weapons array, so we can start the game unarmed. And that's it. The shooter system is now fully integrated. We can pick up weapons from the ground, fire, reload, and switch between them seamlessly. Remember, you can join our Discord channel for more information. Thank you so much for your support, and we'll see you soon.